Hello and welcome to Steve Learning Note channel, where I share my learning notes. Today, we have an exciting topic to explore. We are going to learn about transactional locking in Cloud Spanner. Transactional locking is a fundamental concept in the world of databases, ensuring data integrity and concurrency control. It enables multiple users to access and modify the same data concurrently while maintaining the ACID property. I'm going to start by explaining database transactions. Then we will touch on the concept of transaction lock. We will investigate how Cloud Spanner resolves a lock conflict. After that, we will see the type of locks in Cloud Spanner. We will see a common transaction pattern example. And finally, we will wrap up with some best practice. What is transaction? In databases, a transaction refers to a logical unit of work that consists of one or more database operations. These operations can include read, write, update, or delete actions performed on the data stored in a database. Let's look on this example of transactions for transferring money from R to S. It begins with starting the transactions and end with ending the transactions. In between are all actions to transfer money from R to S. In particular, step number 3 and 6 are applied on applications layer. Transactions are designed to follow the ACID property, which stands for atomicity. A transaction is atomic, meaning it is treated a single indivisible unit of work. Either all the operations within a transaction are successfully completed, or none of them are applied. If any part of the transaction fails, the entire transaction is rolled back, and the database is left unchanged. For example, if one of the operations on the left is failed, then all operations will be aborted. Consistency. Transactions are designed to bring the database from one consistent state to another consistent state. The database must adhere to predefined rules and constraints throughout the transactions. If a transaction violates any of these rules, it is rolled back and the database remains unchanged. For example, if S account is blocked, then want to cancel transfer. Therefore, the deduction on R will be rolled back. Isolation means that each transaction operates in isolations from other concurrent transactions. It means that the intermediate state of transaction is not visible to another transaction until it is committed. This ensures that concurrent transactions do not interfere with each other and maintains data integrity. Durability. Once a transaction is committed, its changes are permanent and survive any subsequent system failures, such as power outages or crashes. The committed data is stored persistently in the database and can be recovered even in the event of a failure. What is lock? A lock is a mechanism used to control access to data during the executions of transactions. A transactions lock ensures that concurrent transactions operate on data consistently and reliably, preventing conflicts and maintaining data integrity. When transaction wants to read or modify a particular data item, it must first acquire a lock on that item. The lock acts as a form of protection, allowing only one transaction at a time to access or modify the locked data item. Other transactions attempting to access the same item must wait until the lock is released. Transaction lock granularity. Cloud Spanner operations acquire locks when the operations are part of read-write transactions. Read-only transactions, on the other hand, do not acquire lock. Meanwhile, read-write transactions is acquire lock, and it is where your write will depend on the read result. The granularity of transaction locks in Spanner is a cell, or the intersections of a row and a column. This means that two transactions can read and modify different columns on the same row at the same time. Consider the following scenario. Transactions 1, TX1, holds a lock on record A and is waiting for lock on record B. And transaction 2 holds a lock on record B and is waiting for a lock on record A. This is a lock conflict. The only way to make progress in these situations is to abort one of the transactions so it releases its lock, allowing the other transactions to proceed. In Cloud Spanners, they solve the lock issue by applying won't wait algorithm. What is won't wait algorithm? If transaction Y, which is a lower priority transaction, hold a resource A, and then transaction X with a higher priority transaction requests a lock on resource A. In this case, transaction X with higher priority can wound transaction Y. Higher priority transactions will abort lower priority one. The priority in spanners is determined by the timestamp of the transactions. The older transactions will have a higher priority compared with the newest or the younger transactions. When transaction Y is higher priority, holds resource A, and then transaction X with lower priority requests a lock to resource A. Then in this case, lower priority transactions will wait until higher priority release the lock. Now let's check types of locks in Cloud Spanner. The first lock is reader shared lock. It is acquired when a read-write transaction reads data. It can be from a select query or when you try to update or delete data with a where clause. Second lock is writer shared lock. It is acquired when a read-write transaction writes data without reading it. So you write blindly. The third lock is exclusive lock, acquired when a read-write transaction which has already acquired a reader shared locks then tries to write data after the completion of read. And the fourth lock type is writer shared timestamp lock. It is a special type of lock acquired when inserting new rows with the transaction's commit timestamps as part of the primary key. This is a table of log mode conflicts. In this example, you can see that if you have a reader shared, it will not conflict it with another reader shared log. Meanwhile, if you have a reader shared logs, it will conflict it with writer shared log or exclusive shared logs or writer shared timestamp log. Let's see another example. If you try to acquire logs, in this case exclusive logs, and then their resource log already acquired by another clients, in this case reader shared, then it is a conflict. So you can take a look on this table to determine whether your transaction will be locked by another log types. Now let's check common transaction patterns that can happen. We will walk through a few practical use cases. Let's check case 1. I have accounts table with 3 columns, user ID, balance, and type. So we are going to use this table for all our cases. In this case, transaction 1 begin a transactions. Then transaction 2 begin a transactions. Transaction 2 select start from accounts where user ID wants. This means that transaction 2 will acquire a read shared log. Why? Because it's read from the tables. In this case, it will lock these 3 cells because it used star over here. Then transaction 1 try to update account set balance 100 where user ID 1. So these update operations will be saved in the buffer. Then transaction 1 will try to commit. In this case, transaction 1 try to get an exclusive lock. Why? Because if you see here, it's using where clause in the updates, meaning that it tries to read. After read completes, it tries to write. Then it requires an exclusive lock. And it tries to require exclusive lock for this cell. But the cell's resource is locked by transaction 2. Therefore, it conflicts. It means that transaction 1 need to wait. Why waiting? Because transaction 2 is a higher priority transaction because it begins the events over here earlier than transaction 1. Then transaction 2 commit its transactions. Now we have C1. Then transaction 2 will release the lock. So only then transaction 1 can acquire exclusive lock. Then do commit and release exclusive lock after that. Now let's check case 2. Transaction 1 begin transactions. Transaction 2 then begin transactions. Transaction 1 select star from accounts where user ID 1. So it acquires read shared lock. Then transaction 2 also select star from accounts where user ID 1. It's also acquired read shared lock. Transaction 1 try to update account set balance 100 where user ID 1. And then this update operation will put in the buffer. Then transaction 2 try to update account set balance 200 where user ID 1. This update also will be put in a buffer. Then transaction 1 try to commit. It enables to acquire exclusive lock because transaction 1 is a higher priority transactions because it begins the event, the actions, earlier than transaction 2. Now it locks the cells. So if you remember the wound weight algorithms, the higher priority transactions will wound the lower priority transactions. So after commits, it will abort the lower priority transactions. So transaction 2 will be aborted. In this case, you should do a retry mechanisms to retry a transaction 2. The last case, case 3. Transaction 1 begin the transactions. Transaction 2 begin transactions. Transaction 2 select star from accounts where user ID wants. So it's acquired read shared lock. Transaction 1 also select star. It's acquired read shared lock because read shared lock doesn't conflict with another read shared lock. Transaction 1 try to update. Transaction 2 also try to update. Then transaction 1 try to commit. In this case, it requires exclusive lock. But since transaction 1 is a lower priority transactions compared to transaction 2, therefore it needs to wait. Now, transaction 2 commit the transactions. It's able to acquire exclusive lock, then do commits. After that, on the other hand, the higher priority transactions will abort the lower priority transactions. Okay, this is the last slide. Let's check the best practice. To reduce waiting time and aborted transactions, we can do the following best practice. First, we can use read-only transactions to perform read-only operations. Because read-only transactions do not write, thus do not hold lock, and do not block another transactions. So if you know beforehand that your application actually only do reads, then use read-only transactions. Try to acquire read shared locks on the smallest subsets of keys to reduce the chance of lock contentions. For example, if you're trying to read data with a where clause or update data with a where clause, try to use the where clause with the small subset of key. The last tips is to only include critical path code within a transactions, avoiding unneeded remote calls or complex long-running business logic to ensure transactions process quickly. This can reduce waiting time and also able to reduce aborted transactions. Thank you for watching this video. I'll see you in the next video. Until then, stay healthy and keep learning. Bye bye.